Okay, so this is on implicit differentiation and fractional powers, and really for today we're just going to do the implicit differentiation, and then we'll come back later and do the fractional powers. You've actually already done some of the derivatives with fractional powers. First, they want you to look at a graph, and if I had a graph similar to this, similar to that graph, and if I had a tangent line at the point 2, 1. Okay. If you consider the graph of y cubed equals, oh, sorry, made a mistake, y cubed plus 7y equals x cubed. Okay, and that would be the red graph. Y cubed plus 7y equals x cubed. Okay, if you consider that graph, there appears to be a well-defined tangent line at 2, 1, and that would be the blue tangent line, tangent to that curve, just touching it. Okay. How do we find the slope of that tangent line? Okay, so when you look at this, how do we find the slope of a tangent line? The problem is, if you go back up and look at this equation, how do you get y by itself? You could factor out a y, but you've still got a y on the inside. There's no way in that equation that you can solve explicitly. Okay, so the problem is we can't solve the equation explicitly for y. That means we can't get y by itself in that equation. That does not mean we can't find the slope. That means we've got to find a different method. Okay? And that's where we use what they call implicit differentiation. To be able to solve and do this by implicit differentiation, we're going to actually use two different power rules. And I want to go through both rules, and then I'll go through the steps for implicit. Okay, so make two columns here. Doesn't have to be very long. I want to look at the difference between the two power rules. Okay, the one that you are used to looks like this. If I take the derivative of x to the n power, okay, with respect to x, the shortcut was you take this exponent times the number in front and then depress that exponent by 1. So it'd be n x to the n minus 1 power. Okay. So example, like if I took the derivative of x to the 5th with respect to x. Okay, we would take that exponent times the number in front, so it'd just be 5x x and depress that exponent by 1. So the derivative of x to the 5th would be 5x to the 4th. And you could write that using y and y prime, or f of x and f prime of x. Okay, now the new power rule, okay, is how do you take the derivative of a y term? Okay, we've always taken derivatives of the x terms. How do you take a derivative of a y term? And this is a different power rule. Okay, it's a derivative of a y term with respect to x. Okay, now here's you still take this exponent times the number in front, so it's still going to be n times y. You still depress that exponent by 1, to the n minus 1. Now here's the difference. Every y term is going to have an extra derivative of y with respect to x. Every y term, this is the difference, every y term is going to have that extra dy over dx. Okay? Some people might call that a differential of y with respect to x. Okay? So on this one, okay, this one involves the chain rule when you take the derivative of a y term. Okay? Okay. Okay, now I want to go through the steps for implicit differentiation, then we're going to do some examples. Okay? So, here are the steps for implicit. And the only time you need to use implicit is when you cannot get y by itself. Okay? First step. Okay, differentiate both sides. Okay, differentiate both sides of the equation with respect to x. Okay, then put in parentheses y terms, use the chain rule. And this will make more sense when I show you the examples. Okay, so that's the first step. Differentiate both sides of the equation with respect to x, and the y terms, use the chain rule. Step 2, collect the terms with the derivative of y with respect to x, or the dy over dx, on one side of the equation. So every term that has a dy over dx in it, or derivative of y with respect to x in it, you're going to get those on one side of the equal sign. Okay? And that's really what you're trying to solve for. You're trying to find the derivative. So factor out the derivative of y with respect to x. Factor that out. Okay, and then you want to get that by itself. So solve for the derivative of y with respect to x by dividing. Okay. Okay, now let's look at some examples. Okay, so let's say, first example, say they ask you to find the slope of the tangent line start with the one that I started with the picture. Y to the third plus 7y equals x cubed. Okay, and we're going to do it at a specific point at the ordered pair 2, 1. I want to know what is the slope of that tangent line at that point. Okay, now on this first step, don't skip this first step. It gets it started. The first step said differentiate both sides with respect to x. So take every term, and this one, basically I want you to write it like this. So it's the derivative of y cubed with respect to x plus, and it's a plus sign in between, the derivative of 7y with respect to x equals the derivative of x cubed with respect to x. So every term, you're taking the derivative of every term. They could actually take the derivative of the left side and derivative of the right side, but I'm going right to the derivative of every term. Okay, so now you take the power rule. Okay, so you're going to take this exponent times the number in front. So that's going to be 3y. Depress that exponent by 1. So it'd be 3y squared. And then if you take the derivative of a y term, it's going to have that extra dy over dx, or derivative of y with respect to x. Then there's a plus sign in between. Okay, and you take this exponent would be a 1 there. It's understood to be a 1. Take that exponent times the number in front. So it'd be 7. And then y, it's actually y to the 0, but y to the 0 is 1, right? And then you'd have that extra term dy over dx. Okay. And now, when you take the derivative of an x term, it's just like usual. So you take this exponent times the number in front. So it's just going to be 3x, depress that exponent by 1, 3x squared. Okay. Now, we actually have all the terms that have dy over dx. They're all on one side. Okay. So that step's actually already done. Third step, factor out. Okay, factor out the dy over dx derivative of y with respect to x. And you'd still have a 3y squared plus 7 equals 3x squared. Okay, and then the last step says solve for the derivative by dividing. Okay, so, and they're usually going to show you're going to divide by 3y squared plus 7 on both sides. Okay, so the derivative of y with respect to x equals 3x squared over 3y squared plus 7. And sometimes the author will do this. He will draw a line right here, and they want you to find it at the ordered pair 2, 1. Okay? So you got to figure the value. Okay, so the derivative of y with respect to x at that ordered pair. Okay, substitute 2 in for x, so you'd have 3 times 2 squared, and substitute 1 in for y. Okay, so 3 times 2 squared, so that'd be 3 times 4 would be 12. 1 squared, you still have to do order of operations. 1 squared would be 1, 3, and 10.
FCCLA pictures are ready at this time.
And then reduce it. Okay? Okay, example 2. Find the derivative of y with respect to x at the ordered pair 1, 3 given. And here's their equation. X squared plus 5x minus 4y squared plus 3y plus 21 equals 0. And like I said before, the reason you have to use implicit, there's no way you can get y by itself. Okay? So you just have to use a different method. Okay, so take the derivative of each term. Okay, so derivative of x squared, don't skip this step. Derivative of x squared with respect to x plus derivative of 5x with respect to x minus the derivative of 4y squared with respect to x plus the derivative of 3y with respect to x. You could have one step in front of this saying derivative of the whole left side with respect to x, but I'm going right to each term. And then same thing on the right side, derivative of 0 with respect to x. Okay? Now take the derivative of each term. So you take the derivative of the next term, you take this number times the number in front. So it's just going to be 2x. You depress that exponent by 1. Okay? Plus, take this exponent times the number in front and depress that exponent by 1. It should just be 5, or 5x to the 0. And x to the 0 is just 1. Okay, now we've got a y term. And it's going to be minus. Take this exponent times the number in front would be 8. Depress that exponent by 1, so it's 8, y to the first. Every time you take the derivative of a y term, you're going to have that extra, because it involves the chain rule, that extra dy over dx. Plus, here's another y term. So you take the exponent times the number in front, is just going to be 3, and then y to the 0, which is just 1. And then it's a y term, so you're going to have that extra dy over dx. Plus, what's the derivative of any constant? 0. And the derivative of 0? 0. Okay? Now you get every term that has a dy over dx in it on one side of the equal sign by itself. You may leave the negative 8y, that term, on the left, or you can move everything over to the right. Doesn't matter. I guess I left the 2x plus 5. It will work either way. If I add, I would get 8y times the derivative of y with respect to x. And if I subtract, the 3 times the derivative of y with respect to x. Okay, the next step, factor out the dy over dx. So you'd have 2x plus 5 equals. If you factor out that derivative of y with respect to x, you're going to have 8y minus 3 left in the parentheses. Okay, then you want to, that's what you're trying to solve for. You're trying to get this by itself. So now divide. Okay, so we're going to divide on this side by 8y minus 3.
Can we please have Decca at this time for pictures?
And 8y minus 3. Okay. Okay, so we'd have 2x plus 5 over 8y minus 3 equals the derivative of y with respect to x. And they will probably draw the line and say this was actually at 1, 3, the ordered pair 1, 3. Okay, so now you've got to substitute that in. So 1, 3, wasn't it? Was it 1, negative 3 or 1, 3? 1, 3. Okay, so it should have had a comma there. Okay, so now sub 1 in for x. And 3 in for y. And find your derivative. Okay, so we'd end up with 7 over 21. And then reduce that to 1/3. And that is your derivative at the slope of the tangent line. And now you would have enough, if they ask you to actually find the tangent line, you would have a slope and you would have an ordered pair, then go to point slope form of a line. Okay? Okay, last example. Okay, find the derivative of y with respect to x for the function x cubed minus 7x squared y cubed plus 4y squared equals a negative 16. Okay, started out, take the derivative of each term. So you'd have the derivative of x cubed with respect to x minus the derivative of 7x squared y cubed with respect to x plus the derivative of 4y squared with respect to x and the derivative of negative 16 with respect to x. Okay. Okay, so take the derivative of this. Take this exponent times the number in front. So it'd be 3x and depress that exponent by 1. 3x squared, there's no y term, so that's it. Minus, looky here, 7x squared. What's understood to be in between here? Multiply. What rule? Product rule. Okay. So within implicit, now you're going to have product, quotient, chain. Okay. So you're going to subtract this whole thing. Okay. Because you're subtracting this. Okay. So product rule says leave the first one the same. So that'd be 7. Well, I'm going to split it right here. So I'm leaving it 7x squared times y cubed. So leave the first one the same. Times the derivative of the second one. So you have to say, what's the derivative of y cubed? 3y squared. And that's a y term, so it's got an extra dy over dx. Plus. Okay, so we left the 7x squared the same times the derivative of the y cubed. Now we've got to leave the y cubed the same times the derivative of 7x squared. Derivative of 7x squared would be 14x. And that's not a y term, so there's no dy over dx on that. Okay, close the parentheses or the brackets. Plus. Okay, now we take the derivative of this. Take this exponent times the number in front, so that'd be 8y. Depress the exponent by 1, so it's just 8y. That's a y term. It's every time you take the derivative of the y term, you have that extra dy over dx. And the derivative of a constant is 0. Okay. This minus sign, okay, that's going to affect this term, and this is one term right here. And it's also going to affect this term. This is another term right here. Okay? So I would probably go ahead and write that out. So it's 3x squared minus 7x squared. Wait a minute. We can simplify that. 21, right? Put the coefficients out front. 21x squared y squared times the derivative of y with respect to x minus, put the coefficient out front, 14xy cubed plus 8y times the derivative of y with respect to x equals 0. Every term that has a dy over dx in it has to be on one side. I don't care if you take them both to the right or if you leave them both on the left. But here's one and here's another one. Okay? I left them on the left. Okay? So I took the 3x to the other side. I left the negative 21x squared y squared times the derivative of y with respect to x plus the 8y times the derivative of y with respect to x. And I took the 3x squared to the other side, so that's going to make it negative. And I took the 14 to the other side, so that's going to make that positive 14xy cubed. Okay? Now you've got to factor out the dy over dx, the derivative of y with respect to x. So factor that out, and you'd have a negative 21 x squared y squared plus...
At this time, National Honor Society, we're ready for your pictures.
Okay, and then divide. So divide by a negative 21 x squared y squared plus 8y on both sides. Now, did I give you an ordered pair? I didn't on this one, did I? Okay, so your final answer is the derivative of y with respect to x equals this whole thing. Okay, negative 3x squared plus 14xy cubed, and it's all over negative 21. You don't have to factor out, if there's something in common top and bottom, if it will simplify it, the author probably will do that. So you may want to check that in the back of the book. But that's as far on this one as it goes. Okay.